electrical engineering, material engineering, uh, basic physics and chemical engineering, material science, even to the data science, even for computer engineering, whichever the domain you are there as my audience for the today's presentation, it's for you, the slides actually. Because when you look at for the renewable energy, the percentage is around 12.9%. In that, actually, the 10.2 is about just the bioenergy. And the remaining, you can see the direct solar energy is just around 0.5%. And that is where people are trying to explore that how we can have in sub-Saharan deserts, or we can the Sahara desert, we can cover it entirely with the solar panels and we can have a lot of energy. And that is where we have to look forward for the alternative solutions. We also have about ocean energy around 0.002%, and that's where we need to look forward for. You can see one of the experiments which is being done by the Microsoft. They put their data centers to the ocean actually to make it cool down, right? So one of the solutions, instead of having a lot of power grids and to have a lot of energies to make them cool down, because this is, I'm talking about the today's time, everyone is talking about machine learning, everyone is talking about AI. If you see every other presentation, every other conference talking about AI and AI everywhere, but when you look at for those data centers to be cooling down, either using chat GPT, you're using any of the domains for the AI based, you need to further look for the which energy solution is going to take care of them. And you can talk about a lot of gigawatts, megawatts power is going for making cool down for those data centers to running actually. So it's not about like you say, I'm in Uganda and I'm in Kampala, I'm not using this or I'm not responsible for those greenhouse effects or maybe all those data centers for the energy, but we're consuming. You're using YouTube, you're using a Facebook, or maybe social other platforms. You're talking about the OTT platforms. Maybe you're talking about maybe the Amazon Prime, or you're using any other resources. Yes, so you're using the resources through maybe high speed of internet, but somewhere those data centers are consuming a lot of energy. And so wherever which of the part of the world we are, yes, we are consuming those energies actually. When you look at for even to the wind energy around 0.2%, hydropower around 2.3%, geothermal energy 0.1%. This is one of the slides I have. Maybe this percentage may vary from place to place, but this is a general perception about the energy consumption which we are doing. So this is the area of the renewable energy which need to be explored further in terms of the energy sources actually. And when you look at for another slide which talk about the energy contribution, around the 19% is coming from the hydropower actually, and then you can see in terms of how much energy consumption is there. But still, we need to look forward for the alternative solutions in terms of the ocean energy or the photovoltaics, mostly for the solar panels, wind energy, bioenergy. So these are the different domain which we need to look forward for the alternative energy solutions. But what is going to be happen when I'm going to have the alternative energy solutions? It's because when you look at for the global power accessibility, around 1.5 billion people have no access of electricity. So where the power grids cannot reach, why don't we have a solution for the solar panels? So every household can have the electricity over there. And that is where we need to look forward for. Those are the young engineers talking about the innovations in the form of energy and power. We need to look forward for all those solutions actually. Around 1 billion people, unreliable instrument supply, need to have the power supply. Around 35 to 40 billion US dollar. That's what the UN estimates. Invest till 2030 to clear deficiency, extending energy grids. And this is what we need to find the solutions actually, that how is when those grids can be expanded to the far end boundaries of the country or the places, so that everyone can have those electricity over there. So rising cost of the conventional fuel, environmental concerns, and finite reserves are forcing us to look at alternative clean energy sources. And this is what I'm talking about today, guys. We have this the high cost of conventional fuels which we are consuming, a lot of emission of all those greenhouse gases, either we can talk about the methane or the carbon dioxide, and all the other gases which we are talking about is going to affect our environment, and we all are responsible for it, either whichever the capacities we are using all those resources actually. Then we need to look forward also, and those resources are finite. It's not about you consume everything this generation and then say by who came in after 2200 or 2100 generation, our next 3 or 4 generations, they say there is no fuels left out for you actually. So we need to look forward for all those alternative, not only the energy sources but the clean energy sources actually. And this is what the need or the demand for the today's time actually. So what could be the energy solutions actually? So those are my colleagues again from electrical background or mechanical or all those domains must be aware about. We do have like the wind energy, we have a biomass, we have oceanic energy, we have a hydro energy, solar, biofuels, geothermal, and the nuclear energy. So whichever the capacity you are, whichever the engineering you have done, either as a machine, whichever the engineering you are doing, you need to find a solution from those one of those alternative solutions of the energy which you can come up with the solutions actually. And when you look at for the winds of the plains are sufficient to power all the electrical demands of India, when you look at for one of the research, and also to the solar additions from just one of the world's deserts could power all global demands actually. So do we have to produce a lot of solar panels? Is that is the solution? Again, we have to see that the solar panels, the life, because someone was talking about last, Professor Salima was talking about the solar panels and how they can talk about the solar grids and how we can talk about the energy consumption. But again, they are made up of what? The silicon. The is it available material abundant in nature? That is okay. But what about after next 20 years for that solar panel? Are we going to have the bigger garbage of those silicon solar panels or what? So we need to again look forward for those alternative technologies, but how they can be reused. The solar panel is being used for next 20 years. Are we just going to buy a new solar panel? We're just going to throw it because we say that it's not absorbing the lot of sunlight. It's not going to give me a lot of energy from it. Shall I just replace it? And again, I'm going to create a lot of waste of solar panels. So we need to again think in that way. It's not just about implementing the solar panels for one of the solutions for energy harvesting, but what is the future for the next generation? What are we going to give the land completely filled of the solar waste, the solar panel waste? So we need to think again in that way that what are we going to produce? What the solar panels also, I see a lot of people are talking about now to the different organic materials they're using for the solar panels, which can be reused. Think in that way actually also. So because this is where we're talking about the innovations for the power and energy. It's not just about I've bought a solar panel, I've implemented, I'm done. What are we going to do? So how we can create as an innovators, we need to think in that way, not just about as an application, how we can build certain innovations so that the energy consumption can be high with the reusable technology actually. So when you look at for the innovation, the need on the multiple front, it's not just about the one which you can say about I'm going to implement it, but what about the energy management? What about the policies which is being governed by the different countries? What is their policy for the energy uses? What are the energy sources we do have? We need to look innovation from them, because every country may have their own challenges, right? It's not about like we are in a cold area, we are in a desert area, or we are in this maybe so sunny area or so dry area or so flooded area. We need to find an alternative solution based on what energy sources we do have actually. And what about the energy storage actually? Because you do a lot of like solar plants, but what is the energy storage for them? Are we going to have a lot of many applications for them actually? So the way we, that's what we say, according to the need, we need to generate those solutions actually. Energy efficient devices and appliances, how are we going to have them? That is also very important. Also, environment friendly processes. That is very, very important to have in terms of the innovations. And lastly, the access, the universal, affordable, and sustainable. Not just about it is available some other country, we brought it and we developed it, some kind of things, and we say we are done. But is it affordable? Having a solar panel every household, is it affordable? Or government is going to provide some kind of maybe subsidy on them, some kind of packages on them. And is that sustainable solution? That is where we all have to think about, guys. So it's not about just a kind of a presentation. Is also as an eye-opening for all of us that how we individual as an our individual capacity, how are we going to contribute for that? So when you look at for this innovation landscape developed worldwide, in this age of innovation, the green theme is showing up a broad and wildering array of new companies. Many promising clean energy startups are hitting the market with the products and services that could radically alter how we think of and the consumer power. The billions of dollars of ventures and the federal support is greatly fostering the green technology and energy innovation. And that's what I believe, like the government is coming because they are the first consumers actually, right? So they bring those funding for those innovations so that we can talk about those, the green energies actually. So when you look at for the Bloomberg, the business week, when you look at for the energy tech, I can see there are a lot of solutions which is coming. Few of them are just listed here. Like you talk about the Atkins Power from San Diego, are testing a clean burial diesel engine. Conventional engines have one piston in one cylinder, but this design has two, an approach that delivers more power in less space and the boost mileage. So what kind of solutions we are going to develop through the innovation? So either whichever the part of the world we are listening to this talk, we need to look forward the solution which is our need and our own solutions. When you look at for the Miasol, again from the Santa Clara, maker of thin film, the photovoltaic modules using the copper, indium, gallium arsenide on flexible polymers that can be used as a roof tiles and can generate electricity as economically as gas-fired power plants. Actually. So instead of having those big, heavy silicon-based solar panels, can we have an alternative solution? And this is where you can see one of the solutions for the photovoltaic thin films, which can also do a lot of absorption. And you can see mostly this construction, you can see lots of this, the skyscraper buildings are coming for 10 floors, 20 floors. On this, they have the glass building. Can this glass be replaced with these thin films? Yes, entire building can be based on the solar energy actually. So you need to have a separate solar panel on the rooftop. You can have on your windows as well actually. So that's why I'm saying every solution comes from the problem you have. It's not like some other country have a problem and they have a solution and say, I'm going to have it here. What is the use of it? You have your own challenges, you find your own energy. You say the Virgin Power from the New York, the slow moving underwater turbines, converting the water flow into the electricity for a nearby community, operations being scaled up actually. So why can't we have this kind of another solutions? Maybe we have near to this, which you can see maybe River Nile or maybe Queen Elizabeth River. We can have this kind of solution so that nearby community who are doing fishing and all can be benefited with this kind of energy. Alternative solution technologies. Solzums from the San Francisco using microalgae to produce the clean and scalable fuels and then green chemicals. Do we have such kind of solutions? And also to the and tech and using the ultra hot plasma to convert this waste, which is from the medical, radioactive, industrial, municipal, and even to the old tires actually. So why can't we have those kind of solutions? You can see now I was just talking about those waste even coming from the solar panels. Why can't we have some certain kind of maybe a solution? Yes, we need to look for those things actually. We see further for another some more because just talk about the innovations, right? How people are doing. There may be some other kind of innovations people are doing, but few of them are listed here. You can see from the hybrid energy technologies based in Canada, the low-cost rechargeable alkaline battery in a flat plate format improve the current rates and the charging times. This is what we can have another solution. The Nexion Limited from London, silicon-based anodes for the lithium-ion batteries, Imperial Innovations Incubator. The SaltWorks technologies from British Columbia to reduce the cost of the desalination of by 50% compared to the reserve osmosis by reducing the power consumption. Aquamarine Power, Edinburgh, Wave Energy Power Front, the D-Light for the solar power system, 12 hours of light after 1 day charging in sunlight. And this is really good. And this basic solar lantern, which is coming around $10, universally affordable for at just $5. So affordable and cheaper cost, and this is one of the alternative solution technologies which you can see actually. So one of the solutions which I recently found, I attended one of the event from India recently. Talk about those some in IITs and Indian Institute of Technologies. They are talking about the technology business incubator, and this is where I always come with a solution that where the government should come with an incubation centers, like you can see in Uganda. Now in Kampala we do have like we have this high collab, another incubation center we do have at UICT, and we have not many government funded projects where they are trying to bring innovations through this incubation center. The government is going to provide you space, the facilities, so that you come with a solution and try to develop as your project can be converted to a product idea. Actually, you can have certain kind of energy efficient inverters. You can have kind of global motor tech, which is going to have their motor design, which is an energy efficiency around 6 to 7 star. Yes, we need to find a solution which is on existing technology and also to the alternative technologies which can come to the market actually. And not just about certain development, also need to have certain solutions. So what solutions based on the new technology? Because today people are talking about, hey, these are all talking about the motor, inverters, they all are old one. Can we have certain new technologies in the today's time of 2025? What kind of maybe nanotechnology people are talking about? People are talking about the process technology, mostly people from mechanical engineering, electrical engineering, process engineering. How do we have a latest solutions? Yeah, maybe the carbon nanotubes have the ability to make the parts of the cars or the aircrafts lighter, influencing the fuel consumption actually. So if they have the lighter weight, less of the fuel consumption, can we have, this is one of those innovations. Catalyst nanoparticles improve the catalytic performance of a fuel cell or the batteries, another improving the efficiency and the performance. Nanoscale devices in semiconductor components can reduce the power consumption per bit processing energy bit. And this is where I'm talking about a solution for your the data centers, which is consuming a lot of power, because all those devices are made up of, again, semiconductor, made up of silicon, germanium. All the semiconductor technologies have huge power consumption, other made of diode, transistor, and all those things required nanoscale solutions for them. Look at for the polymers are being explored as a new fundament for solar cells. I've seen recent technologies about the thin films, then to the polymer based thin films. So a lot of solutions are going to be there as a part of innovations actually. Storage of the methane or the hydrogen for the fuel cells by the carbon nanotubes. Yes, we need to look forward for all those alternative solutions. So I'm not saying you do all of them. Depending on what is your expertise, knowledge, you can adopt any of those solutions which you can see. And another solution which I can say about an integrated renewable energy based energy plant in Norway, supplying the commercial and the domestic to the building. So you can see they have like a university, they have a R&D data center, they have a commercial or the domestic building. They all are going to have a different source of energy. They are going to be having from the energy plant. They do have now to the wood chips, another energy is coming from the bioenergy oil. It is also coming from the landfills, also coming from the heat pump, also coming from the sewage and all. They're going to generate energy from that, and also to the solar thermal collectors actually. So they're going to get an energy plant and energy from the different resources, and then it is going to distribute to the different. So how we can have certain innovative solutions to make it possible for the youth and the people who are going to have a new life. Right? It's not about just you have only one solution or maybe wood chips and you're only depending on that one solution. How we can have certain other solutions also, so that we can have a kind of energy plant. We can have a multiple solutions over there, and we can talk about the integrated renewable energy solutions actually. So this is what I believe. Another solution I just talked about now to the photonic integrated circuit, which I can talk about now to the recently to my computer engineers who are doing mostly to the computer engineering and mostly to the electronics engineering, talking about to the next generation disruptive technologies. Because when you look at for the photonic integrated circuit, which is a solution for the normal engineering of semiconductor or the electronic integrated circuits, which can give you the 50% less mass and power, 100% times the size reduction, also to the higher bandwidth and data rates, no cost redundancy. This is what we are looking forward for the solutions as an optical perspective, optical domain, or solar fiber, or maybe optical fiber solutions from the photonic integrated circuits. So how do we have all those solutions using those integrated circuit which can consume the less power actually in the data centers? And this can have an integration of a lot of optic, active, and the passive devices. This is what my PhD domain about developing to the photonic integrated circuits, which is a combination of both active and passive devices. And you can see the size which remain around very few millimeter size, and to the micron size actually means less than size to the grain, but you can see how a PIC transmitter looks like actually. So this optical communication with the photonic component can be very smaller in size actually. And when you look at for the solution for that, you can see another solution which is completely from the electrical node power of WDM to the photonic integrated. We have a space saving we do have a space saving, then we do have a power saving, and also to the low cost. And this is where we're talking about an alternative solutions for the clean energy and to the green energy as a part of the power energy as a innovative solutions. And you must be surprised that okay, we have this technology, but how are we going to implement? And this is what I can show you one of the case study which is being done by the ST Microelectronics. Within they developed a photonic chips in a collaboration with Amazon and launch into their data centers actually. And this is what you can see. The link is provided. You can go through with that link and you can see at the solution that how they have applied it as a photonic chip, which can be further implemented or developed for maybe for the quantum photonics, quantum integration of those photonic chips altogether as a hybrid solutions. So this is where we need to look forward for as a solution as well, actually. So lastly, when you talk about the strategy for innovations, definitely, innovation already alone is not enough. It's just about you develop something and you say, now I've done something now. The new business models are also required, and also to the focus on both technology push and the market pull. If there's a demand, if there's a need in the market, there must be a demand for that actually. So if there is no required, I don't know what kind of R&D innovation has been done over there actually. And bottom-up energy entrepreneurship ought to be encouraged. Example, you can see one of the examples I just found for the South Asia, where the millions are mostly in the rural areas who have no access to the electricity, use local biomass. Like for an example, the Husk power system uses an old diesel generator fitted with the biomass gasifiers to generate power for community of 600 families now. Village level microgrid. I'm not saying you do it for the entire country. Can we do at a small grids? Small power grids can be made with the integration of different technologies. Yes, could be a solution. That's what I'm saying. Every country, every community, every locality have their own issues, and it can be solved using their own innovative way of solution. So the way you have resources, according you can make a solution, not depending on some other. Someone is going to give you resources, and then you're going to develop that solutions actually. So strengthening both the seed and the late stage support to innovators and entrepreneurs. This is very important because the integration of the complementary grassroots technologies is very, very important, where the multiple people work together actually. And public procurement as a public tool, the government should become the primary customer. That is what is going to be. Like government says, like this is our building, we are going to have a solar consumption. So first you become a consumer, and then people will follow you. That is what I believe is going to be. And this greenhouse gas reduction can be treated as a public good, because everyone, it's not about like you and me, any part of the world have to look for a greenhouse gas. It's not about like I'm consuming less, but I'm not part of it. I'm using my maybe OTT platforms. I'm watching movie on the Netflix. I'm watching movie on the maybe YouTube, and I'm not part of this the greenhouse gas emission. We are responsible somewhere, because you're talking about those movies watching on maybe Netflix, somewhere connected to the data center, maybe in Kenya, connected to the US, all the way through optical fiber you're connecting. But running those data centers somewhere in the US or another part of the world are consuming energy, any source of energy, and huge energy in the form of the giga watt actually. Right. So we are responsible somewhere. So we all have to look, or you can say we all have to be a good public and consuming those resources. With this, I would like to thank Mr. Vincent for giving me this opportunity. Thank you once again for your attention, and thank you so much for listening to me. I'm here for an open discussion, for a Q session. If you have further questions, since being in Uganda, I'm always available here. Whenever we can look forward for all those solutions where the government and academia and industry work closely together through those startups, through the consultancy projects, so that and young engineers at the university level can develop the solutions, and then further can be implemented in industry and then to the government level. And this is where we need to look forward for the alternative solution and technologies. So with this, thank you so much once again, guys. Thank you so much for your attention. Thank you so much for listening to me. And this is Dr. Mayur. Thank you once again to all of you. Have a wonderful day and a weekend. Over to you, MC, for further QA session. Thank you so much once again.
Thank you so much, Dr. Mayur, for your deep and rich presentation. I liked how you emphasized on what the innovation really needs for us to take this grid economy to another level. Without wasting any more further time, I would like to invite one of the participants here to give us closing remarks on how this whole event has impacted us. Then from there, we'll have a closing prayer and call it a day. Thank you.
Thank you very much. Before the it makes the final closing, I just want to thank all the presenters and also the participants for today's event. Dr. Mayur, thank you very much for the presentation. I know this is your area, also part of your area of research. And next year, we will continue with this innovation and green economy. And another presentation later next year will be about the proposal writing, because so many participants were asking the same question about writing proposal in this area and so on and so forth. So this is the area that we're going to focus next year in this area. I would like to thank everybody for the presentations, and I'd like to invite Anthony to come and make the final remarks, and then we'll ask the MC to make the prayers. And Dr. Mayuri, as you promised, we're waiting for you at the the venue. So after that, you'll come here. Thank you.
Thank you so much. I'll be there shortly. Thank you.
Yes. Good afternoon, everyone. I've been honored to give the closing remarks. My name is Katongole Adam, and I am a student member of IEEE, part of the IEEE Bara University section, Bara University of Science and Technology. And I'm a member, quite a member of very many IEEE technical bodies. I'm a member of the AESS, which is Aerospace and Electronic Systems Society. I'm a member of the IEEE Computational Intelligence Society. I'm a member of IEEE Computer Society. I'm also a member of IEEE Industrial Application Society. So I've not been a member of IEEE Power and Energy Society, though that brings me to actually thank speakers who are privileged to hear from very inspiring and experts who showcase the vital connection between energy and technological.
Excuse you guys.
So a huge thank you to all the
now,
experts,
bear with me.
to Dr. Engineer, I think Mr. Arthur. Yes. So a huge thank you to the experts we had here today. It's actually not easy to actually meet this insight. So a huge thank you to Dr. Engineer Sophie Salem. You have really sparked off the fire. You have ignited the fire I have for energy, because I'm currently doing some work in artificial intelligence. So really thank you, Dr. Salem. You illuminated the future of PV system optimization. We're also privileged to hear from Dr. Mayur, who broadened our perspective on innovation in energy. And one key insight I didn't know that ST Microelectronics is actually developing photonics chips for Amazon. So I'm really privileged to be part of those who have gotten that insight, and I've actually gotten a deeper understanding of the innovation landscape, particularly in the power sector. So a heartfelt thank you to the organizers. An event of this caliber is only possible through tireless effort and dedication. I want to take the moment to specifically thank the organizing bodies, the Global IEEE, the IEEE Uganda section, and especially the IEEE Power and Energy Society, to mention but a few. And finally, a very special thank you to the local leader who has spearheaded the effort to bring this week to life. Please join me in thanking Engineer Vincent Olema for his exceptional dedication and organizing prowess. Thank you, Mr. Vincent. As members of the IEEE, looking ahead, as members of the IEEE, we are architects of a sustainable energy future. The innovations discussed today, from solar diagnostics to photonics chips, are the blueprints for the efficient, reliable power that fuels economies like the AI critically depend on energy. Thank you once again for making this hybrid event a resounding success. let the ideas and connections sparked here continue to burn brightly. We wish you all a wonderful reminder of the day. We hope to see you at future events of IEEE Power and Energy Society, and so let's go forth and power the world. Thank you so much.
Thank you so much, Adam Katongole, for that amazing closure. And I would just add a little bit more on what you said. I would like to also congratulate all the student universities around. I've seen where at least almost all the universities have representatives, both physical here and online. Online, I can see the Makerere people around. I see Ronnie, the chair. We are here with people from ISBAT, then Barra University, as Adam had said, then also Ndeje people are around, which is me. So now this brings me to the closure of our session with I would like to ask everyone to humble themselves for a short prayer as we close this day and take our innovations to life. So, Almighty Father, we thank you for today. We thank you for making such an event possible. And we pray that as we leave this room and the session, may we pick whatever has been spoken during this event and may we actually implement. May you show us the way and may the innovation really happen in Uganda. In just name I prayed, amen.
Thank you. So thank you very much, everybody. The event now comes to an end. I would like to thank everybody, the presenters, the participants. Next year, many activities are going to come. Please join online and virtually. So don't worry. And we have another event coming up probably end of January. So just be on lookout to attend this. But with all this now, I just want to close this event and enjoy your weekend and share. I'm going to share the presentations later today. Thank you.